routed now, today, because I cannot lose any more data. It would also be a good time to ask for a dedicated hardware RAID controller and 4 hard drives.
Using that $55 hard drive would be great, though.
You can do a software RAID. I almost lost my software RAID the other day. This is something that is not on my email. The controller was faulty. And when you have a faulty controller, it can do a whole lot of damage because it can kill all drives all at the same time. It can just write improper data onto the hard drives all at the same time. So RAID is no help in that case. Okay. Fortunately, it did not overwrite enough to cause really permanent damage. I was able to rescue most of the file system, but that was bad. That tells me never to buy another Marvel-based SATA controller. That was bad. It's not worth the money. Okay, so that's another thing, and then there's one more thing. Okay, there's one more thing which is kind of in general applicable to this class. And this one is kind of interesting too. I sent this one to all my colleagues. I can bump up the font size so you can read it too. So first of all, I will go to this link here just to see, so that you guys can see the original article. It's not something that I made up. I cannot make up anything quite this spectacular, by the way. So it began. The article begins with 20 years have passed since the publication of the report "A Nation at Risk," which apparently is a report saying how the math standard has been decreasing or has not been emphasized in the education system, and as a result, the country is put at risk because people are not as math savvy as they should be. And it shows here which warned of dire consequences if we did not reform our educational system. This report, not unlike the Sputnik scare of the 50s, offered tremendous opportunities to universities and colleges, such as this one, to create and sell mathematics education programs. Now, in computer science, we also promote the education of mathematics because without math, it's pretty hard to do anything in computer science. Okay, it can be networking, can be programming. Maybe application does not need a lot of math, but other than that, everything requires math. And unfortunately, the marketing of math has become similar to the marketing of creams to whiten teeth, gel to grow hair, and regimen to build a beautiful body, blah, 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 blah. So if you read the rest of it, the gist of this is we are wasting tax dollars, okay, by promoting the education, of math. And if you go, let's just skip it, okay, because it's really kind of like a boring read if you read the whole thing. But you are more than welcome to do it. It's on WashingtonPost.com. And here we have some conclusions as, math doesn't seem to be important. We should not be wasting all that money. Those who do love math and science have been doing very well. Our graduate schools are the best in the world. This nation at risk has produced about 140 Nobel laureates since 1983, about as many as before 1983. But what the study or what the author did not mention is how many of these people are of the first or second generation of immigrants, or they are immigrants to begin with. Okay, because the question is whether people who are educated in the United States since elementary school have the necessary background to get the Nobel Prize. Okay? And the answer, the question was not answered. As for the rest, okay, people who are not particularly loving math and science, there's no obligation to love math any more than grammar, composition, curfew, or washing up after dinner. I don't know about that. Why create a need to make it palatable to all and spend taxpayers' money on pointless endeavors without demonstrable results or accountability? And basically, the last statement is saying, we'll probably survive this math evangelism as well, thanks to the irrelevance of pedagogical innovations. Now, the last part here is surprising, okay? I was surprised. I was blown away by this part here. The writer is the Professor Emeritus of Mathematics, Statistics, and Computer Science at the University of Illinois at Chicago. So we are not talking about some lawyer saying math is not important, I just need to chase after ambulances. No. We are talking about a retired professor who used to teach at a well-known university in disciplines that require a lot of math, if not just math itself. Okay? So what do you guys think?
Wow.
Yep.
I remember when I was completing my algebra requirements, there were some students that asked the professor, well, why should I know this stuff? What does it mean to me? And then when they put to me, well, it has to mean something to people. Because the professor was saying, you can apply it to medicine, to engineering.
Mm-hmm.
And I guess just recently I was reading some books that's something like, for example, public relations.
Mm-hmm.
It wasn't quantifiable before, but now it is.
Well, you can read my feedback here too. I agree with you that I think math is important and it should go beyond. The author basically said, if you're not learning it in elementary school, it is not important. Everything that anyone needs in math, they can learn it in elementary school. Okay, anything beyond that is useless. Okay, that's basically what he claims. So this is my take on this matter, and you guys can just ignore that and take a little dose at this point. So out of the context of the career of a programmer, so let's not even count programmers because obviously programming requires a lot of math and logic. Math is needed to calculate the break-even point of owning a more expensive but more efficient vehicle. In other words, if I drive 40 miles a day round trip, okay, mostly on the highway, okay, is it worth the money to buy a Corolla versus a Prius? Corolla is less expensive, a Prius is more expensive, but it also saves fuel. So the question is, I know the Prius will save me enough fuel to make up for itself for the price difference at some point. The question is, where is that point? Is it in 5 years? Is it in 10 years? Or do I have to keep my Prius for 20 years to break even? That's the question. Now, there's an answer, there's a solution to this equation. But to set up the equation, now it does not involve, there's no sine and cosine, there's no tangent, there's no exponent, there's no log in this calculation. It's all linear. Okay, if you do not, consider inflation, it's all linear. Okay, but the question is, can you set up that equation? Now, without math training in middle school or high school, I don't think someone can set up the equations to solve the variable, the unknown, which is the number of years that you need to break even. Are you guys kind of following what I'm saying? Okay, so I think that is important. When you purchase a car, that is an important consideration. I mean, all things being equal, I want to make sure I can save money down the line, but I also don't want to spend a lot of money up front. Yep.
With the throwaway society that we live in, but how many consumers would even care?
Well, when gas prices go up, I guess we'll see. Right? It just has to jack up to say $4 a gallon, and people will have to think about it. Yeah.
I think also something we need to think about is the education that the author had gotten, because if he had a higher level of education in elementary school than what most people get, then that changes things a little.
Yeah, but I don't think elementary school, math can even set this up, just yet, because I went through elementary school in Hong Kong, and I'm pretty sure that I could not set up something like this using just elementary school math. This is algebra. This actually contains algebra, because you have to look at the number of years as x, and then you say, okay, I want this equation which represents how much money I'll be spending with a Prius, assuming x is the number of years, and this is how much money I'll be spending with a Corolla, using x also as number of years. If I want to make these two equations equal to each other, what do I have to make x be in order to make them the same? So it is an algebra manipulation, and
Yeah, when I went through grade school, algebra just came out when I was getting out.
Mm-hmm.
So I wasn't taught that.
I think there's a great divide, of how algebra or math was teach. Do you guys know who's Dave Larrabee? He teaches database, access classes. He said that he is one of the last generation of the before the change. So when he went through school, math is everything was rigorous. Okay, everything was rigorous. And then a few years after his education, the educational system changed dramatically, and people were not focused on getting stuff down, getting the fundamentals. So they changed the way things was taught after he, shortly after his generation. It is also important. Math is also important to understand surveys, polls, and studies. Probabilities. What is the population that you are polling? Okay. What is the uncertainty? Okay. The population. This class has, let's say, 30-something people. I do a poll on 10. Okay. And all 10 people say blah 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 blah, or the average of these 10 people says blah 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 blah, and that's the average number. How can I infer from that poll of the overall population of this class? Okay, and are you guys seeing what I'm saying? Okay, if I randomly take 10 people of this class and ask some question related to this class, let's say. Okay, number of computers that you own, or number of computers that you use on a daily basis. Okay, let's say the average within these 10 people turns out to be 1.65. Okay, because most people get in contact with more than one computers a day. 1.65. Okay, so that mean of this sample of 10 students, of 1.65. How sure am I about the entire class? The average of the entire class is about 1.65. I know the average of the entire class is probably not exactly 1.65, but what is the probability of the class average being 1.4? What is the probability of the average of the class being 1.8, 1.7? Now with statistics, you can actually understand all this stuff and know, well, assuming the distribution is normal, and you can actually say that, well, with a probability or with a certainty of 99%, I know the average of the class cannot be more than 2.2. Okay, you can actually draw conclusions like that when you understand statistics. And I think that is important. Okay, when you look at the polls, the studies, the surveys, and whatnot. What is the sample size? If the sample size is really big, yes, the study is good. I mean, if the sample size is small, the variance is big, and the standard deviation is like this much. I mean, and those are all important terms to understand, all these studies. So I think, people really should understand all that stuff. And obviously, since I'm passing the roll sheet, even to understand my syllabus, it takes quite a bit of math already. 6% of absence is considered excessive. Okay, so how much is 6% out of 16 weeks? Well, approximately 1 week's class meeting, which means 2 classes, right? The weighted average of the exams, how I calculate your overall score, that's math too. Okay. And we talked about this in this class already. It is needed to figure out whether the extra $500 of a souped-up computer is worth it. As I said, most people will argue and say, well, if I spend $500 more today, I don't have to upgrade the system, for another year. But that turns out to be not true, because $500, depending on the percentage of increase of performance, may buy you only weeks or at the most months. Okay, 1 or 2 months. Because of Moore's law. Moore's law says your computer, for the same price, will double the performance every 18 months. Do you guys remember that? So now you can actually equate $500 for this much.